Hey, welcome back, everybody. We're going to start Unit 9, which is on magnetism, and this is pretty much our last unit. And so let's go ahead and jump into it. So I don't know if you noticed, but electro, it's kind of like you look at electronics, you look at electricity, and then if you look at magnetism, which is north and south, you have electromagnetic fields, right? So this is going to be talking about current with magnetism and magnetism with current. So let's go ahead and break down our notes a little bit. So first off, I want to ask you, what is electromagnetism? And you might want to stop this for a little bit, just kind of think about our discussion that we would have. And so, what I would like to do is kind of split our paper in half and just talk about electricity for a little bit. Okay. So, here we go. So, electricity is really a form of energy. And that form of energy, is a movement of electrons through, let's say, a wire, or maybe see like a wire. So you have like a piece of wire, maybe that you have this to your charger of your phone, and then you have the plug here. It doesn't matter. But what you're going to do is that you're moving these, electrons through this wire. And when you're doing that, you're creating some kind of field, and we're going to talk about that in a little bit. But you have these electric charged particles, that these electrons, remember electrons are those things that look like this, and they have a negative charge, and they are around the atom, which we're going to talk about here. And so if you take a simple atom, let's say a simple atom of hydrogen, helium, but hydrogen and helium are just they have one or two electrons, and so you have what we call in the center. This is the center is the nucleus, and usually what this has in it. So if you kind of want to break it over here, maybe this is like the center, right? Which is also the nucleus, which has uh, positive charges and protons, and they have a mix of these two in there, right? And you can find that on the periodic table. But if you take a simple electron or a simple atom, and then you count up the electrons, and maybe they would have in the first shield. Remember the first shell of the electron. There's only going to be two electrons, right? And as you move out of to the other particles, or I'm sorry, rings there. You have two here, you have two there, maybe you have two there, maybe you have two there. This is what we call has 8 electrons. Now, 8 electrons, remember, is a solid. Really, you can't. It's hard to break that down. It likes to be stable. So, but most of the time when you're dealing with electricity, you're dealing with a flow of electrons. And a flow of electrons most likely does not have 8. They might have 4, they might have 3, but what they're doing, they're constantly sharing, giving off electrons and sharing electrons. And what they're doing is that they're creating a field, or a what we call a movement. So here we go. So there's your electron. So remember, you have protons, electrons, right? Protons are in the nucleus, and they have a positive charge. And then electrons are in the outer shells, which are negatively charged. And so this is really the basically of electricity, that you want something to flow or happen. And that's really important for this concept that we're learning today. Okay, hope that was a little bit entertaining there. But now let's go into maybe electric charge. So maybe you have this wire here that has some current flowing around. You have these electrons flowing around this wire, and it's creating some resistance. And also, what we're going to do is we call it static, which is a column. And we're going to talk about this a little bit later. But this is kind of like an electric charge, like static. You might have heard of static friction or electrical pulses. It's about attraction and repelling. So remember, when you have a positive and a negative, I think the old saying is that opposites what attract. And that's really what we're thinking about when we do columns, is that we're thinking about, okay, are they attracting or are they repel? Remember, they're also, it's called repel, which if they are maybe the same, they're going to propel. So we're going to talk about that in a little bit later, okay? So there's two types of electricity, and maybe we can talk about movement, I should say. But the first type is what we call static electricity. Now, static electricity, if you think about it, you can generate static electricity, right? Go ahead and walk across like your grandma's floor, maybe just a carpet, and if you kind of take a carpet, and what you can do if you take your feet, so take your feet, terrible looking feet, I know, these are feet, and then if you drag drag your feet across, you are generating electric current, or you're generating what we call static, and this build up of charge, and you're picking up electrons. And then this is where you become like, you're electrified, if you think about it. And then you can kind of take your finger and say, "Hey, I'm going to shock you," or you touch you touch maybe something metal, and you shock yourself. This is one of the reasons why you touch your car before you put the gas. If you're at a gas station, and you're filling your car up with gas, a lot of the times you should always kind of touch your car too, because you don't want to spark the gasoline. There's a thing about that I read before, where you should always kind of like touch the car before you put the gas in, because you build up electric shocks in places that you have been. It's kind of interesting, as that seems to work. But anyway, if you take a balloon, you kind of take an old fashioned, let's say an old fashioned balloon that you blow up, and you've probably done this before, and you have a wall. Here's a wall, and you rub this on your head. So here's your head. Here's you. Here's your head. That pencil's not really that good, so I'm gonna use one of these here. If you rub this on your head, and you're picking up, your hair is transferring electrons. And so what happens is that if you take that balloon and put it, terrible balloon, I know, on the wall, it's going to stick, because the electrons are they are sharing on the wall. And so that's kind of like a static electricity. The next type is what we call current. This is where maybe you take your cell phone charger, and you have the block go like this, little block like this, and then you have your phone, right? And so what you're doing when you plug your phone in, you have electric current. You have what we just talked about. We have a flow, what we call a flow. And this is a current of electricity, is what you're making things flow. And that's what charges your phone. It's what charges your cell phone, right? Because you have to have a cord. And I know some they have these chargers where that you can place your phone on, and it picks up particles too. Well, that is a different kind of charge. It's a different way of transferring electrons, and it really creates like a magnetic field. And we're going to talk about that in just a little bit. But the thing is, you want to understand and take away from this is that there's two types of electricity. There's static and there's current. Current means there's something flowing. We're going to talk about that later. Okay? So hopefully that was a little bit more understanding. And now let's go up to the next thing. So we have electricity. And when you plug in your cell phone, I keep going to this because it's a realism. We can talk about it, and we all hope we have a cell phone that we plug in and charge. When you're plugging in your phone, there's some kind of electric field that comes around this, obviously, and then we don't see this. But what you're doing is that as you have electricity that's flowing through this, so is when you have current flowing through this wire, you're picking up what we call magnetism. And magnetism is something that they generate around the wire. And if the more windings, let's say the more windings you have in that wire, just say it has more of an electric current. We're going to talk about that later. But we have this thing called magnetism. And so it's Magnetism is really defined as the physical force produced by moving electrons. Remember, we are still moving electrons. If we don't have movement of electrons, you don't have a magnet. And to kind of help you understand this electric charge when form attracting and repelling, I want to show you a picture in a little bit of a. It's in your vehicle, but it's called a starter. It's called a starter, and it's in your car. And I'll show you a little picture later, but it kind of looks like this, and it has like a little engagement pin like this. And I think there's a little it's called a stator. This is kind of like a stator, and what this is like a turn thing, and this engages what we call a flywheel. So in a gas powered car, you have the flywheel engages your crankshaft, which starts your motor and stuff like that. There's a lot more into that. But this starter, if you ever take it apart, it has what we call a big old thing of metal in it. And then around that metal, I should say metal rod, it's a metal rod. It's all just completely like a metal rod. It looks very similar like this. It's metal, and around that metal rod, you have magnets, which are north and south. And if you ever played with a magnet before, which I highly recommend you do, you have a north and then you have a south magnet. What happens is that, remember, opposites repel each other, and you're going to get this game of, hey, I don't want you, I don't want you, I don't want you, I don't want you. You have this both ways. And what happens when you put those together, you have this generating current, and then it creates this magnetic field. So I don't know if you want to look that up someday. It's kind of nice to kind of look at these. If you ever take one of these apart before, you know what? That's something that you should kind of do in your life. I know it's kind of weird that not to take one apart, but it's a good learning strategy if you are interested in magnetism at all. But anyway, let's keep going. So really, you're taking it really involves electrons of atoms that orbit the nucleus of the axes. And so we talked about the atom, and as current is running around this nucleus of this axis, you're creating some kind of electromagnetism. And if you think about it, this is what our Earth does, right? This is what our Earth does. So that should not say the Earth. That should say the sun. I mean, that should say that should say the Earth. Uh, and in the Earth, we have what we call the North and South Pole, right? And you have this magnetic field, this big old magnetic field around the Earth, and this stops us from asteroid collisions. And then when we enter the atmosphere, when space shuttles are re-entering the atmosphere, they burn up. It really helps us from the sun rays too, that we don't get burned, right? Without this electromagnetic um, this barrier, if you think about it, um, it's we would be fried. We would be fried instantly by the sun, because the sun's rays are really tough, right? And the Earth has a way to kind of stop that, and for meteors to hopefully burn up in the atmosphere and not hit your house. It does occasionally happen sometimes that they don't always burn up, and then they sometimes hit meteorites. And what happens is that, how does this work? Is that, I know I'm going off topic here. I'm trying to help you out a little bit with this. Usually, this is what I usually do anyway. In the Earth, you have what we call an inner and an outer core. So these are cores, and when these things are spinning, it creates this electricity, creates this movement. Which, if you think about it, this movement is like highly metal. And as that metal is moving, what do you think happens? It creates magnetism. So as this liquid hot magma, or you call it liquid hot metal, very hot, as it's moving around, it generates what we call a magnetic field around the Earth. And so without that, we would not have this magnetic field. So think about that next time that you might want to look into it. So you have north and south, right? South and north. And you want to, if you ever have a magnet, you can kind of see how, things are kind of hitting each other and going around. And then from, north to south. So for example, we have, a compass, we have the north and we have the south. Well, if you think about it, is this really true north? Is this really true north? Because think about it. If your compass is pointing towards north, does that mean your compass is north or south? And so if you ever look at a compass and if it's pointing towards north, uh, is it really pointing to the north? Because occasionally throughout history, these things do swap sometimes. The north becomes the south becomes the north. This has happened a couple times throughout the earth. You might want to look that up. I'm not going to test you on it. But if you look at magnets, and magnets are really awesome because we have a magnet in our world, right? We have magnetism in our world. This is how our compasses work, our not GPS, but like our magnets in our system. And so a magnet is nickel, iron, and cobalt. And so if you think about these three types, if you have iron and nickel and cobalt, you have what we call a magnet. Okay, so if you have a penny, it's not, pennies used to actually be some kind of cobalt, if you think about it. But what makes a this is very magnetic. So if you think about like a coin, people thought that, nickels are magnetic. You can try it. Try it with a penny. Try it with a quarter, and just try it with some steel, and it's magnetized. But what's not a magnet? I mean, wood is not, and plastic and copper. Now you might think, oh my God, really? What, copper? Really? You have to understand the electrons. It's all about the electrons. And wood, remember, wood is a different type of material. Wood does not have a very easily flow of electrons, easy flow of electrons. And so, and plastic doesn't either because of the different molecule structure of the bonds. It's very dependent upon that. And obviously, if you think about it, steel or metal, plastic is not metal. Think about how you bend it. How you bend it. Wood doesn't generate anything, right? It's just the makeup. Copper actually is a very good flow of electricity if you think about it. But we're not going to do this. We're not going to go much into this detail. I just want you to know that electromagnetism is the two of these combined. This one produces this one. This one produces this one. And so they are kind of like they produce each other, right? This kind of says, here, I come help you, I come help you. And I can't live without you sometimes. It's like one of those things, relationship. You can't live without the other one. And this is kind of what generates your stuff. All right. So going through this, what I kind of want to do now is go through some people that were kind of really important for this. And this is kind of where your homework's going to lie here. And so the first thing I want to kind of discuss on this is the first person that comes up is this guy, Ben Franklin. Ben Franklin is one of our founding fathers, and he was kind of like a diplomat. But he had a science and inventions, and he did the famous kite experiment. I don't know if he kind of went out and he had this kite. I can draw a kite, and he thought electricity and stuff like that. So now you have what we call Ben Franklin, right? Ben Franklin is one of the important things that you're going to read about. And now you have, let's see, the next person I want you to know is Michael Faraday. Michael Faraday is very important when you do electromagnetism. It's a hard word to say, but he's the father. So you're going to be doing some homework. He's the father of electromagnetism. Look at the date of where he was producing this, and you're going to find out that, hey, there's a lot to him. And he's made a lot of contributions to chemistry as well. And if you're in electronics, you need to know who Michael Faraday is. So he made so much, and you're going to read about this in a homework assignment that I have for you. The next person that you should all know about is Thomas Edison, the light bulb. And he was very important with the style of electricity because we today we take it for advantage is that we don't have kerosene. What they used to do back in the olden days, they used to have these kerosene lamps. I don't know if you ever saw them, but they look like this, little lamps, and they have little kerosene, and they give off light. But old cars used to have kerosene headlamps. So if you drive an old car, like maybe like a Model T. I'm talking old here, guys. A Model T Ford, I think that's what it is. The headlights were actually made out of some kind of kerosene, I believe. I read that, and so this really what changed a lot because then the light bulb kind of made this extinct, and people's houses were becoming less protected because they don't have fire in them because of the candles and stuff like that. And kerosene is flammable. Then you probably know this person, or maybe you've heard of him. But Nicholas Tesla, which is Tesla Motors named after of, very instrumental with AC and DC power, and this is where Thomas Edison and Tesla really they kind of butted heads here because they were trying to invent the DC and AC batteries that we have today. When we buy batteries, we buy DC batteries. AC is alternating current, which is in from our houses. So if you go to your plug, like this. It's probably not like that, but anyway, your plug in your house has 120 volts. So when you plug your phone in, you're getting 120 volts, but you don't get 120 volts from the plug because when you plug your phone in, we go back to your phone again. Your phone cannot handle that many volts, so it has to be reduced somehow. And so we're going to talk about a transformer eventually later. But 120 volts is what we get from our house, which is called alternating current. And our phones transferred into what we call DC current. We're going to talk about those later. Okay? So these guys were kind of butting heads back in the day. You're going to read something about these I think it's called the War of the Currents. Yeah, it's called War of Currents. And you will read about that and answer some questions on that. Okay. So to kind of finish up today and our lecture, I just want you to know these last couple things. The common uses of electromagnetism. The common uses of electromagnetism is one, motors, generators. Let's just go to MRIs, magnetic resonance imaging, vacuum cleaners, food blenders, hair dryers. There's so many I can name here, and we don't have time. But they all have some kind of things with electromagnetism. And so if they have a motor, it's most likely going to have electromagnetics. Okay. And so that's why sometimes if you think about this while you're writing this down, if you take your laptop, if you take your laptop, and take a paper clip, and it will stick to your laptop. It will stick to your laptop because your laptop is generating some current, is generating some magnetism. So take something metal, maybe take a paper clip, take a staple. So take a staple and put it close to the computer, and what's going to happen? You're going to find out that they're sticking to each other. So how did it started? I want you to know this is that Ben Franklin really kind of opened the door a little bit to this. With his kite flying, but I want you to read a little bit about Ben Franklin because that's something that in electronics that you should always know about electricity. Michael Faraday, we just talked a little bit. We saw his picture. He said something about magnetic fields can produce electricity. So this is kind of where the electromagnetism is kind of flowing a little bit, kind of being introduced. And then you have Edison, which is the DC current for short. And he was trying to figure out, they were trying to figure out how am I going to get electricity into my home. And this is, if you have power lines, right? You have these power lines that, you have the city, which is kind of like the current. You're generating current, right? That current gets transferred into these power lines, and these power lines, I don't know if you ever see these or not, but they have these little things on the power lines are called transformers. And those transformers, what they do, they limit or reduce the current, because if this amount of electricity that's generated and gets transferred into these power lines, if this went into your house directly, you would pretty much fry everything in your house. You would pretty much fry everything in your house. I mean, your house will almost pretty much catch on fire, because this is so much electricity. So if it wasn't for these transformers to limit the reduction of electricity down, you're safe. But we want to make sure, how do we get this to your house many miles away? I mean, these are miles away. And then how do we make it work with our stuff in our home? That's something that Edison has thought about. But then you have Nicholas Tesla, which says, you know what? What about alternating current? So when you read about this in your homework, you're going to figure about, who kind of has the benefit here, who has the better idea and who has recognized for this. So you're actually going to read about the DC and AC, and make sure you know what direct current and alternating current is too, please. And this is kind of where they become, it's the war of the currents. And the war of the currents is, kind of say AC, DC is more prevalent. See, so batteries, if you get some batteries, like A, double A, triple A, and etc. You have direct current. Okay. AC is from from the power lines that you have. And most of our electronics, pretty much all our electronics, use direct current. If we have like a remote control to your cell phone, they have a cell phone battery, all that good stuff. So batteries, and then communication technologies, and they're just so much with this stuff. And so that kind of brings us to our close to our first lecture on electromagnetism. And I'm hoping that electromagnetism makes more sense to you, that you have electricity and magnetism and they work together, and one cannot live without the other one if you think about it. Okay? And just make sure you understand what's going on with the two types, and make sure you kind of know a little bit about atoms and how it's generated a little bit, okay? And so hopefully that was good. I will see you when I see you. Bye.